Okay, good morning. Right on time and right into the topic. Cryptowall this morning with Jonathan Kleinsma.
Yeah.
You have the floor.
All right. Before I start on Cryptowall, quick update on BotConf. We actually pissed them off apparently because they're now DDoSing the sinkhole. The sinkhole is now down. So if you're receiving reports, it will be down for some time. So I'm going to be talking about Cryptowall, but mostly what this talk will be is looking into the history of these guys, so what they've been doing over all these years. Because I know a lot of people are looking at the latest version, are looking at 3.0. A lot of people jumped in on 2.0, but I don't think a lot of people actually knew what they were doing before all those versions. So I'll quickly introduce myself first, and then I'll jump into the history immediately. So I'll start off with the first version and basically explain how this version worked, and then from every version I'll just show the changes. So I'm not going to explain everything for every version because then we'll need more than 30 minutes. But it's just going to be the single changes. And at the end I also have a sort of a word of caution about these guys. Continuing on, I'll show the infrastructure. I'll show some interesting discoveries I made while I was investigating these guys. I'll show some tools I've made, which are going to be in GitHub. And I'm going to thank some friends who've been sharing samples or information. So I don't think I need an introduction that much. I'm a guy with an opinion, so I have Twitter. That's sort of the thing. If you're on the internet, I have a blog. So let's just start. So the first version of Cryptowall, when they started, they didn't name themselves Cryptowall. They were doing something everybody was doing at the time, which is cloning CryptoLocker. So this was back in November 2013, and this is basically what you were seeing. You know, so kind of similar to what CryptoLocker looked like at the time. They only swapped out the logo, slight modification in the GUI because they couldn't mimic everything. You know, but pretty much the same. But they weren't the only ones. You know, everybody was doing this kind of stuff. You had tons of these clones floating around. But yeah, so encryption at the time, they locally generated an RSA key pair with WinCrypt, so the Windows crypto API. Files they would encrypt were slightly larger because they added a small tag so they could find back the files. Added a checksum hash from the file when it was decrypted, so you could confirm if it was correctly decrypted. And that was basically it. So everything was local, even the private key. So it's kind of interesting. What they needed to identify system was like a unique system ID. And this is, they have implemented this in the first version, so the clone. And it's still used in the latest version, so the Cryptowall 4.0, if you can call it that. And basically it makes like a string, which is a concatenation of a bunch of information, so the computer name, volume serial number, processor information, and your operating system version. Take a string, take the MD5 from this, hex notation, and that's your unique identifier for your system, basically. So they could identify multiple systems behind a single IP. Communication protocol, really simple, just plain HTTP. Basically, when an infection would start, it would report in with like a campaign ID, which is nothing more than an identifier. So on their backend, they could just filter on specific campaigns. So let's say something was being spread via email, they would tag it with email 1. Something was spread via exploit kits, they would tag it exploit kit 1. So they could just know where it was coming from and possibly what was the most successful way to spread around. So it checked in with the unique system ID. What happened on the backend is it made an entry in the database with this unique system ID. The CNC responded, you know, I've made this entry, it's okay, start up. The client did another request, and again with this unique system ID to identify itself. And what the CNC responded with was a download location with a kind of archive, a file blob, and it contains some GUI stuff and some other resources for the payment processing, that kind of stuff. After it received it and it did its thing, it would just report back and say everything's fine, I'm done. So if you look at what it actually looked like on the wire, it was just this. So you have a post. What was interesting about this post, the location of this post URL is actually a key. It's an RC4 key for the rest of the data, only they sort of scrambled it. Basically what you have to do is to solve this, you just have to sort it on the ASCII value of the characters in this path. And then you have the correct RC4 key. They just scramble it up a little bit. You know, in Python it looks like this. Pretty simple. The data that's actually in the post request is just hex encoded, so you decode from the hex, takes the RC4, and then you get your decrypted request in this case. So it's sort of the same thing I showed on the other slide. The first thing you have the brackets. The first thing they have is like a unique command number, and you get your campaign ID and then the system ID, which it checks in. In this case, the response. One more. Yeah, in this case, the response was actually the download location, so the file blob. Also, the encryption on this was using the same key, so the client could also decrypt it. Pretty simple protocol. Small detail of it is that it does a form post, so form URL encoding, and the actual parameter of the data was just the last or the highest value in the key after it's been sorted. So the protocol itself is actually pretty simple. It's just the curly brackets. In between that, the first thing is always the command ID. And the command ID, after that, you have data. You can see it as parameters to a function. So the command ID is basically a function, and whatever comes after it with the pipe symbols are just the arguments for these functions. Pretty simple. So if you look at an example, this is, for example, the first check-in a machine ever does. So command ID 1, it's just register the client, basically. So after that, you got your campaign ID. In this case, Wolfgang is the campaign ID. Then you got your unique system ID in which it checks in. After that, there's a number which is basically an index on a table, so that it would know which kind of system you were running. If you're a Windows 7, Windows XP, Windows 8, just for identification. After that, they did some stuff for their architecture, so it would know if you're running 32-bit or 64-bit. They also wanted to know if it was running elevated, so if it had full privileges on the machine it was running on. And in the beginning, it also needed the remote IP address. And the reason why that was is because their CNC infrastructure is on Tor. So they don't get client IPs. There's no remote IP address they could use. And the way they set it up is that they have a proxy server, which is owned by themselves, which is set up by themselves. They run Nginx on this with Privoxy, and basically what it does, every request is upstream to the backend, which is inside Tor. Pretty simple setup, but if you kick down that server, it would be done for a while. Now, in the beginning, there were actually, payment-wise, if you wanted to unlock your files, there were a lot of options, which was kind of interesting. You could pay with MoneyPack, Litecoin, Ucash, PaySafe, Bitcoin as well, but there was just a lot. So targeted file types, there's a whole bunch. I'm not gonna talk about all of them. Basically, they're just the file types you would expect to see on a normal machine of people using documents, their pictures, their music, their videos, just to catch whatever would be interesting or vital to somebody using his machine. So a little bit later, February 2014, they actually updated. They removed the name. They went on to a different name, called themselves Crypto Defense this time. So they picked up their own name. Ransom notes kind of changed. It wasn't a GUI, inside the application. They really made their own design of this. It's no more cloning of CryptoLocker. They had a small text on there saying your files are basically encrypted using RSA 2048. The ransom notes would be dropped in every directory where you had files that were encrypted with how decrypt, HTML, TXT, URL. At the bottom, they explained how you get on the payment server to get your files back, and you had something that was a personal code, which they called it, which is just a way to get you to pay specifically for your key to get your files back. Now, one thing that changed from this version is that the campaign IDs were not random words or that kind of stuff anymore. They were actually these kind of things. So it was def with some kind of number behind it. These numbers were incremental, and between all these different numbers, you could see small changes in the binary. So this is just development. This is just version tracking in development of their malware, basically, or ransomware in this case. So slight change. So the red stuff went away, which was the GUI blob being retrieved. The first part is still the same. It needs to check in with a unique system ID. But what changed is it now sent away the private key. So the CNC server now would have the private key instead of it being still on the system. The server would acknowledge that the client sent the key, and then it would report in how many files it actually encrypted on the system. So network-wise, small change. There was an extra post request. You saw some data in there, and quite obviously you see some artifacts of the RSA file blob, basically. So what's kind of interesting, the way they implement this, they use the legacy crypto API from Windows, and basically the crypto API CSP stores keys you generate in your profile. They have like a certificate management, key management, but it stored the private key on the system again, so a copy would stay. And people made a tool for this. People were decrypting this. It's all nice. You could help victims. And at some point, Symantec published about this, and in less than 24 hours, and they had it fixed. So they pay attention to what's being published about them. And with this flaw, basically, they fixed it. They moved the name. They trashed the name because it was bad. People knew you could decrypt it. So they went on. They called themselves Cryptowall 1.0. And it was in March 2014, so pretty quickly. Campaign IDs changed again. Instead of def from crypto defense, now it's CW. Again, version numbers would be incremental. You would see slight changes. And you could also see they were experimenting with some stuff. So there were some Tor versions in campaigns, and these versions would actually talk on Tor directly. So no more proxy servers, they would directly connect onto Tor. And they also made a CW 404. There were no changes. They probably just thought it was a funny campaign ID to use. Again, some slight ransom note updates. Made the thing blue. Some small cosmetic changes. Now says all of your files are protected with strong encryption. But encryption also changed. So instead of generating anything locally, it would actually request a public key from a RSA, a public-private key pair, from the CNC server. So no more private key on your system. So again, small change in their protocol. First thing, still the same. It has to check in. The server has to acknowledge the client existed. Instead of sending back the private key, it would actually retrieve a public key from the backend server. And the server would reply with an MD5 checksum from this public key, so the server would know it had the correct one, basically. So the server says, okay, you got the right key. Client comes back later to report in how many files it had, and that was it. So it also did something interesting. It added exempted countries. So it would not encrypt if it saw any of these countries being the source of the infection. So, Russia, Belarus, Ukraine, and Kazakhstan, they were all, okay, if you would get an infection, your IP would be reported. It did a geo-IP check. It would respond with a country code. Inside a Cryptowall, there's like a CRC32 hashing of these country codes, and would check it against the list. And this was the list they implemented in their first Cryptowall version. So they were excluding old Soviet Union countries. So moving on, October 2014, they popped up again, new version, Cryptowall 2.0. So first spotted in emails from IRS, just file attachment, usual stuff, fake document, it's not a document. Slight update on the actual ransom notes. They added a 2.0 behind it, just to identify, hey, it's a new version. They also did some stuff with the infrastructure. So this was what we had on the clone version. This is what we had on the crypto defense. But they had more versions that were running directly on Tor. So it wasn't all of them. They were still experimenting with them because there were some issues with it at times. But you had a lot of Tor versions directly, so no servers to take down. They also went into the affiliate business. It was kind of interesting. It sort of, they got in guys who would spread for them and would get a cut of the pay if somebody actually paid to get their files back. And you would see these crypt 1 to, it's like, currently it's on like 3,000 or something. There are a whole of a lot. You could sort of see that it was affiliates because in between numbers would disappear, so affiliates would drop off. It wasn't like consecutive version numbering that would just go off and on. You could see different versions or different campaign IDs appear, some of them disappearing over time. But that was basically the whole change. So I think the biggest change here was that they just implemented an affiliate system. So instead of them spreading around, monitoring their system, they would get other guys to also help with this. So further on, January 2015, so this year, they appeared with 3.0. But before that, they sort of took some time off. So, Caffeine also noted this on Twitter. 18th of November 2014 was the last time they updated binaries on their deployment servers and the last binaries you would see from exploit kits. So they took some time off, like maybe a vacation or something. November passed, December passed, still no samples, still no new stuff from these guys. January came, New Year, still nothing. But January 13th, they were back. 3.0 in this case. So they just took some time off. Again, slight cosmetic changes on the ransom notes, new version, new naming of these ransom notes. Because they were quite static, you could actually use this to detect some stuff. Internally, they made a change in the protocol that when it responded with the checksum of the public key, it would also respond with a lock screen. So instead of the malware having this embedded, it would generate this on the server side, which means they didn't have to build new binaries every time when they had new domains for the payment system. It would just generate this on the fly, so they could use old samples. This was all dynamically generated on the back end. Again, networking change. They like to play around. They like to develop this kind of stuff. So they didn't do Tor. They didn't do their own proxies. They moved to I2P, which was kind of interesting. So, setup changed to this. Only problem was it didn't really work so well. I2P doesn't seem to scale for them because their servers went down the whole time. Like every time we just go down, this is the decrypt service. So basically the servers where you could go to pay to get your get the key to get your files back, but it just didn't work. You would get errors from time to time like this in Russian. So infrastructure change after the I2P stuff. They figured out, this doesn't work. We need something that's good. So the old proxy servers, they would maintain themselves. You could take them down, and then it would be done for a while. So what they did is they employed something they're currently still doing. They would hack websites, so old WordPress, Joomla, Drupal, and they would put small PHP files on there, which were just proxy scripts, small scripts using curl to upstream requests. And this helped because talking to all these individual hosters to take this stuff down takes forever, and some of them don't even reply. And at the same time, you actually want a copy of this because you want to know, what is that real server they're owning. You want to take this down. It just improved for them. It helped them to stay active much longer. They also, maybe they got a new partner, I'm not sure, but they added Armenia to the whitelisting of exempted countries. It was kind of interesting. Maybe they had a new partner which says, I'm not going to spread it and don't want to be having issues in my own country. Could be. And in some versions, they also had Iran in there, but not all versions. I only found a couple of samples that had this kind of whitelisting, so I'm not sure what is going on there. One thing they also added was that they changed the crypto. They made it faster, actually. They did some optimizations. So instead of using the RSA key to actually encrypt the files, they would generate an AES-256 key per file. Then use this to actually encrypt the file. Then they used the public key they could get from the server to encrypt the AES key. It was faster. Streaming cipher AES, way faster on big files. If some guy was connected to a file share, this was way faster. You didn't have to hear his machine buzzing up because it was encrypting all the files. They also slightly had to change the file format, of course. So every file was prepended with an MD5 from the public key. So it could confirm if it had the key, if it was right. Then the encrypted AES key, and then the encrypted file data. And they also expanded their list of targets. So 312 instead of the 146 they have had since the beginning. There was a lot of obscure files, a lot of stuff for photography, so raw files for photograph files, a bunch of design documents, some programming files, C, PHP, ASP, also some backup DBs, SQLite database, that kind of stuff. These were all in their target list now. They were expanding. So moving on, the current version, which they're now using. I've updated these slides, I think, 4 days ago before I came here, so they're as recent as I could get them. This is November, so last month, 4th of November. They did some change, so cosmetic changes on this part. The version number is gone, so there's no 2.0, no 3.0. People are calling this the 4.0 just for consecutive numbering, and I think it's good to identify this new version. We don't know what they're calling this version. So slight change in the naming of the ransom nodes, help your files. But they were also quite confident about what they were doing. They were saying, you have become a part of large community Cryptowall. Congratulations. They were mocking whoever they were infecting, and they would continue it on. In the message, they would also say, unfortunately, these sites, so basically the sites they were referring to were the payment websites. Unfortunately, these sites are temporary because the antivirus companies are interested that you cannot restore your files but continue to buy their products. They were mocking the industry and mocking the people they were encrypting their files from. Doing even more, Cryptowall project is not malicious and not intended to harm a person and his or her information data. They were just mocking. Nobody seemed to do anything against them. They were just having fun. However, the 4.0 change wasn't on all affiliates. Some are still using 3.0, some are using 4.0. Sometimes it drops this, the ransom nodes where they make fun of people. Sometimes it doesn't. It depends on what kind of affiliates they have. So I'm not sure. I think they're also kind of experimenting with some new stuff. They also changed the communication protocol, probably because there were a lot of publications on how you could decrypt the stuff. So for one part, you couldn't plainly just decrypt it by doing a hex decode and doing the same scrambling. What they did is, if you look on the PHP files they have on their proxies, they did a nasty trick that first tripped me up as well. Basically, they take this key and they convert, so in this case, it changed from just a post location to the actual parameter. So the last part in this thing is the key. What they do is they convert every character in a string to an integer. So apparently PHP, which I'm not really a fan of, when it gets a character and you cast it to an integer, it just says, hey, that's not a number, I'll make it 0. So instead of giving any exceptions, I was doing this in Python, and Python is a lot more compliant that way and starts complaining about this stuff. So what they were doing, if you walk down that string, basically all the characters became 0, and then you had an 8 and a 5 in there. 8 plus 5 is 13, and this was basically an offset in the actual hex data. Then you could do a decode and you get the RST4 again. Just a slight change to, I'm guessing, stop automation of this stuff. Kind of annoying, but fixed it. I have a tool for this. I'm gonna release later. You can just calculate the offset really easily, but it just, it broke a lot of tools for people. Now, through all this history, I want to give a word of caution. Basically, these guys learn and profit from everything you publish on. I know it's fun publishing about this stuff. It's fun pointing out stuff that's wrong. But they learn from this. So the first CryptoLocker clone, they probably stopped it because of the takedown. They wouldn't refer it with the name. I'm not completely sure. But they changed from Crypto Defense to the first CryptoWall because somebody pointed out there was a flaw in their crypto. They fixed it, made a new version because the name was sort of tainted because people saw it in the news as being bad in encryption. You could just decrypt all the files. So from CryptoWall 1.0, they sort of moved to the hacked website system and did some Tor stuff. Just because of frequent takedowns. It was pretty easy to kick them down. You just took this proxy server, you got it taken down, and then for a while they couldn't do much. And from 2.0, they did the same thing. They tried some Tor stuff, ITP. This wasn't related to publications, but their own findings. So the ITP stuff didn't work out. It was kind of buggy. They moved to 3.0. They went back to the hacked websites. And then from 3.0 to the current version, they made a change because somebody made a publication about them. There was a flaw in basically how their proxy servers would filter requests. So you could send stuff like a server stage request. It would upstream to one of the backends. You would get a server stage page from the backend. They figured this out, and overnight they changed it, fixed everything. So, these guys are smart. They adapt quickly. They read what people are publishing about them. And if you find any flaws, I suggest not publishing these. I know it's fun. It's like kind of cool when you find something. But these guys, they really closely monitor this stuff. You really don't want to explain to them what they have to do to fix stuff. You don't want to give them a free pen test or free advice how to improve their operation. So if you do find something, I don't know, shared with trusted partners or in trust groups, there is law enforcement working on a case. Can't say who, but if you want to work with those, send me a message. I'll forward you to some guys where you can help out, do something about these guys instead of helping them with their operation, basically. So, infrastructure. This is the generic infrastructure they've had for a long time. They just did some layering on the top, so connect directly on Tor, I2P, which upstream to the Tor service, or their direct proxy servers. So on the left, you have the Privoxy server, which just does the upstream request into Tor. This can be the public payment systems they have, or when a client initially checks in. So the initial check-in is actually into the backend server. It has the blue icon. If you find it, the fave icon is actually this blue thing. Don't know where they got it. The payment website is in between. It has the orange icon. You connect to it, but it would actually upstream to the backend. So it's just another proxy in their whole system of proxies. And the operators would also connect on several separate backends. These were also upstreaming onto the other backend. And if you find this login page, you found one of their backends. They can do all kinds of management. They can have account management for their affiliates. They can build new samples. They see geographic locations where they had infections, statistics, all that stuff. But there's more behind it. These guys love proxies. Like seriously, everything in their whole infrastructure is proxies. They proxy all the things. Put layers on layers, so it's really hard to find out where they are and what you can do about it. So you need to explore this, find every next hop to actually get to the back end. Some information, the outside proxies are engines with privacy to upstream to specific hidden services, so either the affiliate page or the payment wall. And the backend, as far as I got, is actually a Debian machine running PHP Apache with MySQL. They also have some validation in this infrastructure. So the tier 1, they actually decrypt the request. They check if it's valid. Tier 2 validates the actual request post location, so you cannot do server-state stuff anymore. And the backend completely parses it in order to confirm what you're doing. And the payment wall and affiliate stuff is similar to tier 2, so just filtering on specific stuff they don't want to pop up. So, interesting discoveries I made over time. So they have this really unique logo they put on the first version ever, and they put on every payment website. Is this just a lock? It's actually part of a big set of icons, and it's just an icon pack they stole from somebody who made this. So Semiographics. I won't name the name of the guy because he doesn't need to be affiliated with this. They just stole his work and put it on their ransomware. A while ago, about a year ago, they were screwing up some internal systems in their infrastructure. So if you did a server stage request, you saw this. So this is a normal server stage request, only if you looked at it, you would see there was actually upstreaming. So we get server status pages from different backends, depending on which proxy you would ask this stuff to. It's kind of interesting. You could figure out their proxies this way. At some point, they were also putting messages. So in their initial packer wrapper around the whole core of Cryptowall. So here's our crypt, a virus, shut up and listen. They like to have fun, make fun of people. But one thing they also do, just like they check up what people write about them, they keep track of new techniques. So in November 2014, PowerTool, a guy from China, he made this proof of concept to run code or actually execute something via compiled HTML files. And he uploaded a POC of this on Mega. No AV detected this, USC doesn't pop up, not anything. So then February 2015 came, and these guys were using this. They used this to spread. And they went as far as to not even remove the name of the original guy. So they just took the proof of concept, they pasted in some stuff to just download Cryptowall and execute it. And then the guy's name was still in there. One more thing, this. If you decode the whole core, you get to this, or Skurva, which is just, if you want to insult somebody, say it to them. It's in there. I don't know why. If you're looking at this, if you get into the whole core, there's the file names of the ransom nodes. And if you go 16 bytes up, there's 4 bytes, which if you decode it, is this. I have no clue, there's no reference to it. But what was interesting at some point, what I found, is that they made a slip up. And they made this slip up all the way in the beginning. So I said there was this compressed blob, which the CryptoLocker clone downloaded, right? Which was this thing. Now, if you looked at it, you saw some artifacts from a PNG header. It's kind of compressed, there was some stuff missing. Now, what it actually was, it was like a small data container. So the first 4 bytes were the size. They can get the whole size. You could decompress it with RTL decompress. And you could get sort of a list of small file blobs indicated with a checksum, with a size, and then the actual data. So I made a small script to decode this because I was interested in what was actually inside. It was a bunch of PNG files, some text files. And if you looked at the images, you got this. It's kind of interesting. They weren't on the actual locker. They weren't used in the locker at any point. If you looked at the HTML files and you fixed it up a little bit, you saw this. Now that's even more interesting. These are the police lockers. Specifically the ones from a group called Reveton, which is a group that has been doing these lockers on Android and web page lockers for a long time. The actual code from processing these payments was the same as the guys from Reveton. The first version of Cryptowall, you could pay money back, Ucash. It's the exact same payments you could do with these guys, their locker. But this disappeared. They went on to Bitcoin ever since Crypto Defense. What's kind of interesting, there was the code, these file blobs were also used for these lockers. First, the old lockers would just request all the different images from the log page from a server, but this one would actually get a file blob, the latest version, which was similar to the Cryptowall stuff. So maybe a lead to the authors. So quickly, I've got some tools. I made a request decryptor, a client, and a server. I'm not going to release a server simply because I said this once on Twitter. I'm not going to release something with which you can patch old samples and actually run your own ransomware operation. I don't like that stuff. I don't like open source ransomware, so I'm not going to help them. So this tool, you can just decrypt the requests and the responses. So you give the post location key, parameter key, would decrypt the response. I made a client, allows you to communicate with the proxies or the backend servers. It's all in Python. You can do it interactively, and I just used it to explore these command IDs. So it's currently broken because of 4.0. I'll fix it later. It's on GitHub. I'll publish it tonight or something. So quickly, thank you to some friends. Brad from our traffic analysis. Go to his website. There's tons of resources if you want to do analysis on stuff. Nick Hoffman for sharing some old samples. Tech Help List is a guy on Twitter who shares a ton of information in his free time. Awesome guy, and there's tons of more unnamed people. And I'm just in time. I had too many slides, sorry.
Non, il peut pas.
Oh yeah.
On a déjà basculé.
Can you change it? Ah.
Any questions?
Oh, there we go, this one. It's 0x3a, which is the hex notation of a column, so 0x3a.
Tom has a question.
Hi, morning, Jonathan. Have you looked into Tesla Crypt? We've seen it very actively being distributed in Switzerland just very recently.
I have somewhat. I've been looking at some of their proxy stuff because what they're doing is they're mimicking Cryptowall. So the lock screen they're copying from Cryptowall, the backend server, the looks stolen from Cryptowall, and they're now also doing the hack proxy stuff, all Cryptowall. So maybe it's my next thing next to still tracking these guys, because I've been looking at these guys since 2013. I'm kind of done with them, so I haven't looked at it too much now, but I will.
Okay, thanks.
Okay, thank you.